So this is a client whose blood chemistry revealed severe methylation impairment. And this is a perfect example for us to demystify MTHFR, which is discussed, popular, and often misunderstood, and explore what methylation really means in health for many clients, the letters, or for many people in general. Understanding that they have MTHFR feels like a diagnosis. It can feel like something very serious. But the truth is, MTHFR is simply a gene that codes for an enzyme, which helps convert folate into its active form, methylfolate. So when someone finds out that they have MTHFR polymorphisms, that is the reality of it. They have a gene that codes for an enzyme that makes it difficult to convert folate into its active form, methylfolate. Yes, genetic polymorphisms can reduce efficiency in this, but there's a key here. The polymorphism is not a diagnosis. It is the epigenetics in the terrain that dictate if that polymorphism becomes functional and expressed or not, and also to what degree. Methylation, it happens in every single cell all the time. It's not solely in the liver. And we can assess how well it is running functionally. Okay, so genetic SNPs are not necessarily always functional in a terrain that is established and is balanced. But we can assess how the functionality of that SNP by looking at the terrain, particularly blood chemistry. So let's explore this further. Now, methylation is one of those core processes that makes the entire system run smoothly. At its essence, it is the body's tagging system, the way we take a tiny one-carbon group, which is called a methyl group, detoxification. Methylation tags hormones, neurotransmitters, and toxins for safe clearance. And so saying, yes, methylation is an issue when it comes to estrogen dominance, when it comes to mold toxicity, heavy metal toxicity, because you need methylation to tag these toxins for clearance. Now, in genetics, it marks genes for activation or silencing. And in the nervous system, it regulates dopamine, norepinephrine, and the stress response. And the catch is, of course, that methylation relies on methylfolate as its currency. So for those with MTHFR polymorphisms, folate conversion is impaired, so they don't generate enough methylfolate to keep the process moving. And this is why we often intervene with methylfolate directly or with other active forms such as folinic acid of B9. Now, as many of you are aware, when methylation is sluggish, the effects ripple throughout the whole terrain. Detox pathways bottleneck, hormones back up, oxidative stress rises, cardiovascular risk increases. Elevated homocysteine, which is the functional expression of this polymorphism, is a cardiovascular risk that will often raise blood pressure and can damage endothelial tissue. And yes, mood stability suffers. Now, so this case, which is directly related to this client's homocysteine was at 26, as you can see in these bloods. That is a dead ringer for poor methylation. And though we did not have genetic testing, I'm quite certain she has homogeneous SNPs. Elevated homocysteine, which ideally is close to 7.5, means that the methionine folate cycle is clogged and the body is simply not recycling homocysteine efficiently. But the pattern did not stop there. On our blood chemistry, you can also see that she has very low cholesterol. So her total cholesterol is at 159. And I will often say that the closer cholesterol gets to 150, the more likely someone is depressed, because cholesterol via pregnenolone builds both your steroidal and your sex hormones. So this woman's cholesterol was very low. And many people are told cholesterol lower is better. Doctors often preach that, the lower we go, the better. But cholesterol is actually one of the body's shock absorbers against oxidative stress. Remember, oxidative stress, free radical species from toxins, from medications such as Tylenol, from viruses, from stress, from poor sleep, oxidative stress, okay? And cholesterol is a buffer against oxidative stress. And this woman's cholesterol was very low, so it was giving me signs. Cholesterol sits in your membranes, it stabilizes them, and it's a backbone for hormone and mitochondrial production. When cholesterol runs too low, like it is in this woman's case, it signals that the body is burning through it to buffer inflammation and oxidative stress. Equally, she had low uric acid. So I like to see uric acid at about 5. Hers is at 3. Obviously, if uric acid is elevated, it's a red flag to most doctors because it correlates with poor purine metabolism. People manifest gout. That's a different pathway. They don't necessarily pick up low uric acid. Uric acid is actually a buffer in your bloodstream for free radical species. And while it sounds nice that it's low on paper in context of poor purine metabolism and gout, uric acid is a frontline antioxidant. And when it is low, it suggests, again, antioxidant defenses are thin and oxidative stress can take a bigger toll. Lastly, we see her GGT marker down at 7. Okay, I like to see GGT between 15 to 25. Now, many people worry when GGT is high. Why? I obviously work in the biliary space, so I'm working with liver disease, gallbladder disease regularly. Elevated GGT correlates with biliary stasis. So your your bile composition has shifted through crystallization, sludge, stones, the gallbladder is struggling to empty it. You're at a high risk of gallbladder attacks. You will often see elevated GGT in these cases. But when it's low, as it is in this client's case, it's a sign that your glutathione system is not keeping up. GGT is very necessary for glutathione recycling because glutathione is obviously the body's primary antioxidant, which is getting a lot of FaceTime today on Instagram with Trump's speech yesterday, but it recycles itself. And your GGT number will explain that to you, how well someone is recycling glutathione and burning through antioxidants essentially. So low GGT really means that detoxification and redox balance are underperforming. Now, when we put these pieces together, her homocysteine is elevated, her uric acid, GGT, and total cholesterol are low. You're looking at a body that's not methylating well, not buffering oxidative stress, and not regenerating glutathione efficiently. It really paints the picture. And her symptom picture matched it. She had fatigue, mood swings, poor detox tolerance, recurring infections. Now, I want to emphasize that genetics, they load the gun, but the environment pulls the trigger. The epigenetic environment pulls the trigger as to whether that genetic polymorphism will be expressed or not and to what degree. I do find that understanding symptoms linked to MTHFR as well as other key SNPs is important, but we can't stop there. And this is why I built a genetics module into the blueprint that Anastasia will show you now. So this genetics module, it maps detox SNPs in a way that connects them back to real physiology. So you can see the difference between a gene and a bottleneck because your genes alone do not dictate outcomes. It is the terrain, the environment, and the biochemical context we just saw on those bloods, for example, high homocysteine, low cholesterol, low uric acid, low GGT. So there's a difference between getting lost in the fear of polymorphisms versus actually understanding how the system is operating, is it expressing, and how is it affecting other systems and to what degree. Now, what did I do with this client if I didn't just jump on the MTHFR train? Well, I look at the entire terrain with an understanding of biochemistry. Homocysteine is not just a bad marker, it's a metabolite that has to be recycled. So recall, she had elevated homocysteine at 26. Yes, this is a red flag. Cardiologists are going to pick this up. I don't always see homocysteine at 26. It's also a red flag for me if it's up at 12. It really should be appropriately at 7.5. When homocysteine is low, it is not a win. This is really a myth in the functional health space that low homocysteine is healthy. It's not, but that's a whole different conversation around excessive methyl factors, CBS gene regulation. We want homocysteine, a certain amount of it, around 7.5. Homocysteine is not a bad marker. It is a metabolite that has to be recycled down two pathways, the methionine folate cycle to produce SAMe and the transsulfuration cycle to produce glutathione. I go into this in much more depth inside of the course, but the framework to keep in mind when you see elevated homocysteine is to provide methylation cofactors. It's not just methylfolate that supports the methionine folate cycle. It's B12, it's riboflavin, it's B6. These are the essential spark plugs that keep the methionine cycle moving to produce SAMe. And without them, homocysteine can pile up and the system can get congested. But there's an art to this. You don't just rush in with methylfolate when you see high homocysteine. You have to balance that methionine folate cycle with the transsulfuration cycle for you or your client's well-being. Because if you produce excessive SAMe, you will have anxiety, you will have agitation. We do not want to recycle homocysteine solely down that pathway. We need the transsulfuration gates open basically. So you provide transsulfuration cofactors. This is the pathway that actually produces glutathione, B6, magnesium, zinc, molybdenum. This will keep homocysteine flowing down into glutathione, taurine, and sulfates. And this is what maintains detoxification capacity and antioxidant defense. Glutathione, amongst many other endogenous, because your body produces antioxidants, and exogenous antioxidants, those that we actually take, provide antioxidant defense for oxidative stress. Yes, this is a really key concept in my work and in the course. Redox balance is very important. Now, yes, in some cases, I use gentle methyl forms. Not everyone tolerates methylfolate, methylcobalamin. There's folinic acid, there's hydroxycobalamin. These may be better entry points. I go into this deeply in the course, as well as in this PDF that I provide to support methylation without overstimulating the nervous system. There's a lot of nuances on this. You could imagine if someone has homocysteine at 26, they've got quite a bottleneck in detoxification. And if you go in there and open that up in an agitated nervous system or where there is constipation or without proper binding, there might be a bit of a nervous system blowout. That's a lot to expose your nervous system to, your mast cells to as well. I go deeply into mast cells in the mold module because we do have to consider our immunological health when we're mobilizing toxins in terms of exposure. Key point, if you push too hard on the methionine folate cycle when you have elevated SAMe without keeping the transsulfuration exit open, you create a bottleneck. And this leads to excessive SAMe, which is what we want, the body's primary methyl donor, but this will spike the nervous system. And a lot of people have intolerance to methyl donors because it's not done properly. There's really an art to balancing this with the client in front of you, taking into account their drainage, certainly, their nervous system, their mast cells, and proceeding intelligently. And something that's often overlooked regarding methylation is creatine. Roughly half of all methylation demand in the body goes towards creatine synthesis. I'm 43 years old. My body is naturally synthesizing less creatine. Half of my methylation needs are going towards creatine. When creatine status is low, the system will waste SAMe, the body's primary methyl donor, on making creatine instead of clearing toxins and hormones. So supplementing creatine when appropriate. Okay, there's context to creatine because you need to gauge kidney function. You need to have good glomerular filtration, but this can free up valuable methyl groups so the cycle runs more efficiently. Which brings me to an important piece that I want to say, that right now in the health space, I'm seeing a divide. There's many practitioners that are focusing on quantum biology, principles of light, principles of grounding, principles of water, and some practitioners are functioning on functional biochemistry. My truth is that it's both. We have to focus on quantum biology and we have to focus on functional biochemistry. Why? Because enzymatic function will drive your mitochondria. If you have poor enzymatic function in the liver, it's going to create excessive oxidative stress, which will impact your mitochondria, and you will have low ATP production. Equally, mitochondrial ATP production will drive your enzymes. They exist in a constant feedback loop. So personally, I try to embody both quantum biology and functional biochemistry. There's not one without the other for me. And yes, methylation ties directly into the redox state of the cell. When methylation slows, oxidative stress rises, and that drains glutathione, your master antioxidant. And when glutathione is low, methylation slows even further. It's really a vicious cycle. So what I'm trying to drive home is it's everything. It's quantum biology, it's light, it's grounding, it's water, but it's also functional biochemistry. It's understanding enzymatic function in the body so that these forces can serve one another. So yes, breaking a poor methylation cycle is not solely about adding B vitamins in a poor light diet, in a poor lifestyle. You do have to restore the electrical charge, the cellular voltage that powers mitochondrial redox balance. Light exposure, grounding, circadian alignment, literally charge your mitochondria. Your mitochondria have a cellular voltage that will have an impact on the electron shuffle within the Krebs cycle. And all of this might sound vague and like biochemistry, but when your Krebs cycle is functioning well, you feel it in terms of energy, cognition, immune resilience, physical stamina. Okay. And I'm dealing with many clients who have cell danger response, who have mitochondrial dysfunction. I go into this in the course, and it's important to understand that quantum principles matters and functional blood chemistry matters, okay? So yes, when I say terrain, I mean methylation, mitochondria, redox, cellular voltage, they are all inseparable. You cannot fix one without addressing the other. Now, this client story, it highlights why impaired methylation matters, and without proper tagging and clearance, you accumulate unconjugated toxins, hormone metabolites, and oxidative debris. And that wear and tear shows up as inflammation, hormone chaos, cardiovascular stress, and premature aging of the system. Oxidative stress equals premature aging, whether that shows up as wrinkles, as gray hair, as inflammation, as brain fog, as emotional reactivity. Oxidative stress has a wear and tear on your cellular membranes, on your tissue, on your mitochondria. So the lesson here is certainly do not fear MTHFR. We need to understand it, not simply take more methylfolate, and use blood chemistry as your terrain map. Elevated homocysteine, yes, it is a dead ringer for an impaired methylation cycle. And when you address it in totality with this degree of nuance, you do not just bring homocysteine down comfortably for the client, you restore resilience to the entire terrain.